Okay, in this video, question 4 of homework part 4, we're going to put together demand of reserves together with the supply of reserves. Okay, so in this situation we have required reserves ratio of 15% and checkable deposits of $535 billion. Okay, and then the slope is 0.15. So I'm going to go ahead and put the slope right here. And then the shock parameter is 59.75. So the shock parameter in the intercept in this bracket here, shock parameter plus required reserves, where required reserves are the reserve requirement ratio times total checkable deposits in the banking system. So let me change all this to times. So this right here is required reserves, and this right here is a shock parameter, and I'm going to hit enter to see if I got it right, and I should get it right. But instead of doing that, I'm going to take this over to Excel and calculate it. And it's 20.5. Okay. Now we got to build, that's the demand curve right here, the demand curve. Okay. Now we're going to build the supply curve, and the supply curve is kinked. The vertical section is the quantity of reserves, total quantity of reserves, which is just the sum of 0 and $81.855 billion. So that's total reserves, the vertical section. The Fed has set its target for the federal funds rate at 8.222%, and because of the Fed's discount rate policy, the discount rate will be 100 basis points higher than its target for the federal funds rate, so 9.222%. And remember, that kinks because the discount rate is a non-binding price ceiling in most cases. It kinks the supply of reserves at this rate of 9.222%. Okay? So at the equilibrium, right? At the equilibrium, we got to know what this value is, right? So we don't know what that value is. We got to plug this quantity of reserves into the demand curve. Okay? So let me go ahead and label the diagram before we move on. So up here's the federal funds rate. That's the price of reserves. The quantity of reserves is just R. This is the supply of reserves. And this is the demand for reserves. And we want to know what the equilibrium federal funds rate is. We want to know what that is. We don't know what it is. We know the discount rate is up here. 9.22%. And the quantity of reserves is 81.855. And so the way we figure out what the equilibrium is right here, we're going to plug this value into the demand curve. And I'm going to do it over in Excel. Okay, so, this should be demand for reserves. Okay, then we're going to close and clear that. So the demand for reserves, this is the intercept. The slope is a negative 0.15. So to get the federal funds rate, it's the intercept minus the slope. Oops. Minus the slope. So it's the intercept, 20.50, minus the slope times the quantity of reserves, 81.855. So the federal funds rate is equal to the target. The federal funds rate is equal to the target. Quantity of reserves, the equilibrium quantity is the quantity of reserves. So the federal funds rate is currently equal to its target. So the Fed really doesn't have to do anything here. If the propensity of banks to hold excess reserves equals 0.003, excess reserves equals what? Well, 0.003. That's the excess reserves ratio, or the propensity for banks to hold excess reserves. We're going to multiply that by the demand deposits, total demand deposits, which is $535 billion. So this is the quantity of excess reserves, right? The required reserves, if you remember, the required reserves are just the reserve requirement ratio times the demand deposits, or that expression there. Whoop, I got to put an equal sign in front of that. So this is, the required reserves ratio is 0.15 or 15%, and demand deposits total at 535. So excess reserve, or required reserves, is equal to that. Now, what's the sum of these two? The sum is 81.855. That value. So the excess reserves plus total reserve, or required reserves, equals total reserves. So let's hit enter to see if we got these right. And we did. Okay, good. Moving on. So we go back to this European financial crisis. The shock parameter shoots up by 1.43. This causes banks to hoard reserves, which causes the excess reserves ratio to rise. The rise in the excess reserves ratio causes banks' aversion to hold reserves to fall by 0.029. So we need to come up with the new demand equation. Okay? So the demand components are the shock parameter, required reserves, and aversion to holding excess reserves, right? So these together are the they help build the we got to put in the demand deposits. So let me move this over here. We got demand deposits. We got the reserve requirement ratio. Okay, so the shock parameter is initially negative 59.75. The reserve requirement ratio is 0.15. The slope of the demand curve is 0.15. And demand deposits are 535. Okay. So down here, the shock parameter increases by 1.43. So the new shock parameter is this plus the increase of 1.43. Okay, so this is the new shock parameter. I'm going to make all these. I'm going to make these red. Okay. And the slope A falls by 0.29. So the aversion to holding excess reserves declines by 0.029. Okay. Now we're holding these things constant here, so we'll just pull that down. Okay. So the new intercept, is the supply the shock parameter plus required reserves, or required reserves ratio, times demand deposits. So that's the new intercept, 21.930. Okay, and the new slope is right there. Okay, maybe what I'll do is I'll extend this out and I'll insert a column and I'll move this over here. And I'll call this the intercept. I'll call this the slope A. Okay. So the original intercept is 20.50, right? The new intercept is, with this new shock parameter, is 21.930. So let's go ahead and hit enter. And we got everything right. So the intercept, if you imagine, the intercept for the black line is probably about here. The intercept for the red line is up here somewhere, right? It's greater than what it was. So the black line intercept is probably about here, whereas the red intercept is probably about right here, right? So we got to extend that out. But then the slope has gotten closer to 0, right? It was 0.15. Now it's 0.121. So the slope, the demand curve's gotten flatter. Okay. Now notice what happens here. The demand curve intersected the vertical section of the supply curve, which means or the total reserves in equilibrium are just whatever reserves are equal to, right? But look what happens in this situation here. This financial crisis has caused demand to shift and rotate out to a point where it intersects the vertical section. If the Fed does not make discount loans, right? In other words, it doesn't make this binding. If it doesn't make any discount loans, the interest rate will jump up to around 12%. But the Fed has set this binding price ceiling at 9.222, right? So the Fed has this binding price ceiling. Now, the way the Fed keeps this price ceiling bound at 9.2222 is it makes discount loans in the amount of the difference between this value here and the original level of reserves. So the federal funds rate is the discount rate, 9.222, right? We got to find what the quantity of reserves is. We don't know what this quantity is here, right? We don't know this quantity here. We got to figure it out. We don't know what that is. But we know the interest rate is 9.222 because the Fed wants the federal funds rate to max out at 9.22 with its current parameters. So what we're going to do is we're going to take this new demand curve and set it equal to the federal funds rate. Okay, and we're going to solve that for R. Okay, we can do it over here. Okay, so I'm going to go ahead and merge these cells together so I can do this down here. Okay, so we got 9.222 equal to the intercept of 21.930 minus the new slope of 0.121 times R, right? I'm going to copy this and paste it right here. And what I'm going to do is I'm going to add this to both sides and then subtract this from both sides. Okay. And then I'm going to copy this and put it down here. And I'm going to divide both sides by that coefficient or that slope. And we've done this quite a few times in this class now. Okay. So R is going to be equal to what? Total reserve is going to be equal to something that's close. That's probably between 110 and 120. Probably about 111. So I'll delete the R there and hit enter. Well, it's 105. Okay, so 105.025. So this new quantity is 105.025. If I plug If I plug that into this new demand equation, if I plug this into here, and I do the arithmetic, I'm going to get a federal funds rate equal to 9.222. Okay. So let's go ahead and finish this off. This is 105.025. The discount rate equals 9.222. And the federal funds rate has risen to equal the discount rate, which is now a binding price ceiling. Okay. What are excess reserves equal to? Well, required reserves are still equal to 80.25, right? So these are my excess, these are my required reserves here. My excess reserves are now equal to what? The 105.025 minus my required reserves. So my excess reserves are now equal to 24.775. Okay. And the excess reserves ratio is the amount of excess reserves divided by demand deposits. $535 billion. So my excess reserves ratio has risen to 0.46. A great question to ask here is, what are my discount loans? Remember this difference here. That's the amount of my discount loans, DL. Okay, discount loans. So my discount loans are equal to what? The 105.025 minus total reserves, 81.855. So this is the amount of discount loans the Fed has to make. Okay, 23.170. If it doesn't make those discount loans, the interest rate would have risen up to here. The federal funds rate would have risen up to here if it doesn't make those discount loans. Right around 12. Okay. Because the Fed makes those discount loans of $23.170 billion, the federal funds rate does not rise up to the demand curve. Right? It makes this discount loan, so it'll keep the federal funds rate at 9.222. Okay. Now, suppose instead of a European crisis, the Fed decreases required reserves ratio to 0.01. So, so the Fed is going to decrease the reserve required ratio okay. So the Fed decreases the required reserves ratio by 0.01. I'm doing that over here in Excel. So I'm reducing this value by 0.01. So the new required reserves ratio is 0.14. Okay. Now that causes the shock parameter to shoot up by 0.93. So instead of it increasing by 1.43, it's increasing by 0.93. Okay. The intercept falls by 0.06. Whoops, the intercept, or the slope. The slope falls by 0.06. Okay. We're holding everything else constant, so that's constant. The aversion to holding excess reserves, the slope, falls by 0.06. The shock parameter increases by 0.93. When the reserve requirement ratio is lowered by 0.01. Okay. So my new intercept, instead of being 20.775 20.5 as it was initially up here. Initially it's 20.5. It ends up being just 16.08. Okay. And the slope ends up being 0.09. Okay, we'll hit enter. And we should get those right. Okay. Now, notice the equilibrium is on the vertical section of the supply curve. So this makes finding the quantity of reserves equal or easy. It's just whatever it was initially, right? So we're right here. The equilibrium is right here on the vertical section of the supply curve. Okay. And that equilibrium is slightly higher vertically than it was initially, right? So initially it was down here, right? So we should expect the federal funds rate to be higher on this new demand curve, slightly higher. Okay. We know what it is on the original demand curve, 8.222. And we know the discount rate is 9.222. What we need to do is we need to find out what the new federal funds rate is. So we don't know what the new federal funds rate is, right? We have a question mark there. But all we have to do is plug in that original value of the reserves, total reserves, into the new demand curve. So let's close that out. So the original quantity of reserves was 81.555. Right? So let's do this. Okay. Let me clear this out. Okay, the new intercept was 16.080. The new slope was 0.09. Okay, so all I gotta do is plug in that original level of reserves into the new demand curve. I'll make this red. Okay. And so all I got to do is copy this down here. This is going to be the new federal funds rate. And again, it should be between 9.222 and 8.222. And it is. It's 8.713. So the new federal funds rate equals 8.713. This discount rate is 9.222. The original quantity of the equilibrium quantity of reserves is 81.855. Okay. Required reserves are equal to what? Well, the 535 times the reserve requirement ratio of 0.14. So required reserves are 74.90. So required reserves fell. Whoop, required reserves are here. Okay, and excess reserves. So required reserves fell to 74.90. Since total reserves is 81.855, original quantity of reserves is 81.855. The new quantity of reserve, or the new required reserves, is 74.90. Excess reserves is that difference of 6.955. Okay. The excess reserves ratio is the quantity of excess reserves divided by demand deposits, and demand deposits are 535. So the new excess reserves ratio is that. Borrowed reserves are still 0 because the supply curve, the new demand curve, crosses the vertical section of the supply curve. So the Fed hasn't made any new discount loans, and we'll hit 0 there. Okay. Okay, so that's what happens when the Fed changes, or when they're so up here we had financial crisis, which puts the federal funds market in what I call emergency mode. The Fed has to make emergency discount loans, right, in the amount of this vertical, this value here and that value there. Here, the Fed decreases the required reserves ratio, which kind of throws a kink into the system. Demand is rotated, shifts in and is rotated counterclockwise. So it shifts in and then it rotates counterclockwise. Okay, so that's what happens when the Fed decreases the required reserves ratio. In scenario 4, instead of the Fed lowering required reserves ratio, or instead of the European financial crisis, suppose economic growth causes checkable demand deposits to increase by $31.03 billion. So let's go ahead and delete these numbers up here. We'll go ahead and delete all these up here. So the shock parameter is still that value. The required reserves ratio is still that. Actually, we'll do this. We'll just pull these down. Okay, so those values haven't changed. The slope hasn't changed. It's still originally 1.150, right? So we go back to the original conditions up here. The shock parameter is negative 59.75. The reserve required ratio is 0.15. And the slope of the equation is 0.15. So that's the initial condition, right? So down here in scenario 4, all we're saying is, suppose checkable demand deposits increase by $31.03 billion. So we're going to take this value and add it to the original value of demand deposits. Okay? And we get a new value. Okay? So what this does is it shifts the supply curve out. Okay, it shifts the supply curve out. The intercept now, remember what the intercept is. It's the shock parameter, which we reset to the original value, plus the reserve requirement ratio, which we reset to the original value, times the new level of checking account deposits. That gives us the intercept. The slope was reset to the original value of 0.15. We hit enter and we should get the correct answers here. And we do. Okay? Now, what does this do? This increase in demand does what? It shifts the demand for reserves up to the horizontal section of the supply curve, right? So we don't know this value here. We have to find out what this value is. This value of reserves. We have no idea what that is. Right? We do know what the federal funds rate is, right? The federal funds rate is equal to 9.222. Because the Fed is going to make the discount rate binding. Right? The federal funds rate was 8.22. With its now higher demand for reserves, the federal funds rate increases up to the discount rate. So this is 9.222. 2. Okay, so we're going to set 9.222 equal to the new demand equation for scenario 4. We're going to solve for that. That's our unknown, right? That's our unknown. Let's do it right here. So 9.2222 equal to 25.155 minus 0.15 times R. I'm going to copy that and paste it down here. I'm going to add this to both sides. I'm going to subtract this from both sides. And then I'm going to divide both sides of this equation by the slope, 0.15. And then it'll give me what R is, right? So if I want to know what R is, all I got to do is delete the space in the R, and I get what R is. R is 106.220. So the quantity of reserves the new quantity of reserves is 106.22. If I plug this value into here, then I'll get 9.222. Okay? And then clear. And close. So the new quantity of reserves is 106.220. The federal funds rate is 9.222 because it rose up to equal the discount rate, which is 9.222. What is required reserves now? Required reserves is the new demand deposits times the original reserve required ratio. So the new level of required reserves is 84.905. The new quantity of reserves is that, required reserves is that, so the difference in these two is excess reserves. Okay. And then the excess reserves ratio is just the excess reserves divided by demand deposits, the new demand deposits. So the excess reserve ratio is now 0.038. Now, at the moment that demand shifts out to here, the difference between this value and that value is discount loans. So at this moment, this difference is discount loans, DL. Okay. So remember, this value here was 106.22, and this value here was what was it originally? 81.855. Okay. Okay, so 81.855 was the original reserves. The new reserves is equal to 106.2220. The discount loans is the difference between the two. So the Fed's going to make discount loans to keep the federal funds rate from rising up to here, right? If the Fed doesn't make these discount loans, the federal funds rate will rise up to about 13 or 14%. Let me close out this. Okay. Now, what the Fed will probably do in this case, instead of making discount loans, what the Fed will do is it will see the original federal funds rate was 8.222, right? The original federal funds rate was at its target of 8.222. What the Fed will probably end up doing instead of a discount loan is it will do an open market purchase the Fed's going to do an open market purchase equal to that difference. So that's what the Fed's going to do instead. It's not going to make a discount loan. It's just going to increase the amount of reserves by purchasing bonds from banks. Okay, that's what it's going to do instead. Okay, we'll get into that later on. So we talked about that in the notes. Okay. Okay, in scenario 5, let me go ahead and delete all this. Okay, so in scenario 5, instead of strong economic growth or whatever the previous scenarios were, suppose the Fed announces that it will set the discount rate at 300 basis points above its target instead of 100 basis points. Okay, so the vertical section of the supply curve is still 81.55. But instead of 100 basis points, it's set at 300 basis points higher. So here's the target, 8.222. So if we add 300 basis points, that's adding 3.000 percentage points. Okay. So this is 300 basis points right there. Right in 300 basis points to 8.222. So we end up with 11.222. Okay. And you can see what happens down here. The supply curve shifts vertically up to 11.222. So it shifts vertically up to 11.222. And the supply curve is at 81.855. So it just shifts the supply curve up. That's all that does. Does it change the equilibrium? No. The equilibrium didn't change. The federal funds rate is still at its target of 8.222. The quantity of reserves is still 81.555. Just double checking there. Okay. Anyway, close this out. Okay, at the new equilibrium, the quantity of reserves is 81.555. The equilibrium didn't change, 81.855. The federal funds rate is equal to 8.222. The discount rate is 11.222. Required reserves in this scenario is what it was initially. Required reserves was 5.35 times 0.15. So required reserves are still 80.25. Excess reserves are the difference between required reserves, 81.855, and required reserves. So excess reserves is the total reserves minus required reserves. So in this case, 1.605. The excess reserves ratio is excess reserves divided by demand deposits. So 0.003. And then borrowed reserves is 0, right? Because we did no discount. The Fed did no discount lending here. The equilibrium is what it was, right? It hasn't changed. If we had entered, we should conclude our problem with 100%. Okay, and that's the federal funds market and things that might or may not alter the equilibrium.